Alright, so this is EM3, and so what we're going to be using is our network analyzer. We'll be doing part A, which is these two 50 ohm loads. We'll be skipping part B because the adapter has walked off, can't find it. Part C is this microstrip filter, low pass filter made for 4 gigahertz, so we're going to see if that works well, and we're going to find the negative 3 dB point to figure out how does this work. So first we are going to get this machine ready to read our 50 ohm load. So we're going to start with the first one, hook it up to port 1. Now you'll see port 1 and port 2 are flashing. This means that there is a signal and it is trying to measure between what is going through port 1 and going to port 2. So that's what we're seeing up here. So first what we're gonna do is just change the display. I have a mouse over here. Change the display number of traces to 1. Alright, so that's a little easier to see. And then, so what we have is S11, which is what we want. So that means that just port 1 is flashing. See, port 2 isn't flashing anymore. So we are seeing only what is being transported out and reflected back into port 1. Now for the first part, we want to look at a Smith chart. So first what we're going to do is set our start and stop frequency. We can do that using this. So our start frequency, we are going to do 100 megahertz. So start, and it's at 100 megahertz. I can also just enter it in, 100 megahertz. Stop frequency, we want 500 megahertz. So I'll do 500 and then M for megahertz. There we go. All right. Next, what we will do is do the format. So format, we get all these nice different options. For this one, we're going to do Smith chart, R plus JX. And so you'll see that we get this. And so it's a little hard to see, but basically there is a spiral pattern. So if I do marker 1, I can move marker 1 and it is changing what is being read. So this is supposed to be a 50 ohm load. It is not reading 50 ohms. So based on this part, we are going to measure from 100 megahertz to 500 megahertz. To do this, we will hit marker 100 megahertz. All right, and you'll see it says impedance, comma, R plus JX. So this first part is our impedance. So it's 51.43 ohms. 51.43 ohms, comma, R is this value. Now remember, this matters. Units matter. So what we have is 3, just look at it a little bit, 306 milliohms. And let's see, 487 picohenry. Alright, so that is how I recorded 100 megahertz. We will now go to 200 megahertz and record the same thing. So 51.2 ohms, 597 mega ohms, 460 5 picohenry. All right, move on to the next one. Marker to 300 megahertz. Continue down the line. So that is 51.1 ohms. 827 milliohms and 435 picohenry. All right, and then marker 400 51.03 ohms, 1.08 milliohms, and 429 picohenry. All right, so I am going to finish, and I will be back once I am done with the second one. All right, so I had switched out and I have done all of the recording. Now, one thing that you must include in your lab report is why are we seeing variation? And then what does this R plus JX mean? It has to do with Smith charts. I know you guys already went over Smith charts. So what does this R plus JX tell us about the coordinate system of the Smith chart? So make sure to include that in your lab report. All right, so for the next piece, we'll be skipping part B and going straight to part C, which is the low pass filter. I'm going to quickly reconnect the cable and hook up the low pass filter, and then we will continue. All right, so I have hooked up the low pass filter and I have connected it finger tight. What that means is that I'm not forcing it, and it is just as tight as my finger grip. I don't want to wrench it because I don't want to break the PCB board. So if you ever handle PCB boards, don't be too aggressive. They can break fairly easily, but you'll see there's no more threads. And we won't be using the Smith chart for this one. We'll actually be going back to format, log magnitude, and remember that this filter is supposed to work to 4 gigahertz, so we are actually going to change our stop frequency. So our stop frequency, we just go over here, stop, that's at 500 megahertz. We want 4.5 gigahertz, so 4.5 G for gigahertz. All right, and that's what we are seeing. Now that doesn't look quite right, but give me a second to format, scale, reference value. Let's bring that down to 0. Enter. All right. When in doubt, turn it off and on. Give me 1 second. All right. I think I found the problem. So right now we're measuring S11. Remember the blinking lights. So now we're going to hit S21. There we go. That looks a lot better. So sometimes this port 2 doesn't blink, but since we have selected S21, which we can see right here, we're measuring log magnitude, S21. So for our display, scale, we'll see that our reference value is -30 dB. So we'll enter in 0 dB, and now we can better see the line. So in your lab report, explain why did we change the reference value from -30 to 0 dB. And that was basically just so that we can see the line better. All right, so what we're gonna do is we're gonna select marker 1. We can select it by pressing in this button. And now we can travel. And so the main thing about this is that we're looking for the -3 dB point. So that means when it goes from 0 and it drops by -3 dB. So in this case, when we get all the way over, we're at -0.1 dB. So we are going to look for -3.1 dB, and that will be our cutoff frequency. So it is supposed to work up to 4 gigahertz, but let's see what happens. All right, so it made it through there. And basically all I'm doing is turning the dial with the marker, and there we go. Okay, so back it up just a little bit. There we go. All right, so I'm gonna call this good, and I am going to record. So there's no table here, but I'm just going to record the value of -3 dB point. And I'm going to record it as 3.604 gigahertz. All right, and now what we're going to do is go back to format, and we're going to look at the phase. So this you really can't see much, can you? So what we can do is make this smaller. So go to start, and let's put that at 1 gigahertz. And let's see. All right, still a little hard to see. Let's do 2 gigahertz. So start frequency 2 gigahertz. All right. So it's a little hard to see, but yeah. So let me go in just a little bit more. 2.5, 2.6 gigahertz. Okay, this is a lot better. So what we can see here is that there is a shift. There, it's very hard to see. There's that little shift right there. So what we can do is go in even further. So go to start. Let's do 3 gigahertz and stop at 4 gigahertz. All right. So we're not seeing it very much, but there is supposed to be, you can see that there's just a little bit of a dink over. That is a phase shift. So in your lab report, I am going to give you this and the picture of the log magnitude, and you have to explain to me first, why did we change our graph start and stop? And then second, what's happening with the phase shift here? What happens with a low pass? You can Google it, low pass filter phase shift. Why is there a phase shift? All right, that is it. I will include the pictures of the setups, and if you have any questions, you can email me at jerica.d.cleveland@ndsu.edu. My email is also attached to the rubric on Blackboard. And if you guys have any questions, like I said, email me. Good luck, and thank you for watching.